Hello. First thing we need to do, sixth period. I realized after you guys left yesterday or Friday that we forgot to fill in the very last three blanks. So sixth period, for any form of, this is condensation to occur, whether dew, fog, or clouds, the air must be saturated. Saturated with what? Water vapor. When condensation occurs in the air above, tiny bits of particulate matter must be in the air. This is why when we did our cloud in a bottle, we had to put smoke in there, something for the water vapor to stick to. Kind of similar to when the condensation forms on your cold drink in a summer day. It just adheres to your glass. It doesn't just randomly form liquid everywhere. It needs something to stick to. And that particulate matter forms what's called condensation nuclei. And it just serves as a surface for that condensation. Alright, so you should have already read the next section. We're going to just dive in here. Section 18.3, Cloud Types and Precipitation. So we classify clouds a few ways. Their form and their height. We are just going to focus on the three main big categories of clouds. So the first one is cirrus clouds. And they are high in the sky, white, thin, wispy. They're often described as having a feathery appearance. They may also be made out of tiny ice crystals. So they're the kind of thin, wispy, flimsy looking ones, very high up in the sky. Okay, the ones that you think of as cloud-looking clouds maybe are cumulus. Okay, the word cumulus literally means a pile. It's the pile of rounded-looking cotton ball looking clouds. They might be flat on the bottom, but depending on how quickly they formed, they may or may not have that. But they're what you usually think of if you asked a 6-year-old to draw clouds. They're probably drawing cumulus clouds. All right. Third type, stratus clouds. And that word, if you think about what we were talking about with rocks, might sound familiar. So the rock strata were the layers of rocks. So now we have strata clouds, and it's the same meaning. It just means layers. So if we look at our picture of the stratus cloud, they're long and they're flat, and they might form in layers. And so they're often described as looking like sheets of clouds or layers, and they cover a lot of area usually. These are the kind of clouds you might think of when you think of overcast days. All right. Next page. We're going to keep rolling here. All right. So when a cloud is very near the ground, or the condensation forms a cloud near the ground, we call it fog. We've experienced that. But for precipitation, which we describe as water falling, not just fog being near the ground, but actually falling, those liquid droplets, because remember clouds are made of liquid droplets, must grow in volume a lot. They've got to get quite a bit bigger compared to the size of the itty-bitty tiny droplets that form when a cloud forms. They have to get about 1,000,000 times bigger. So how are they going to get 1,000,000 times bigger? We're going to address that right here. But for right now, we have one additional term to introduce here. So water in the liquid state, that's below 0 degrees Celsius. So it's liquid, but it's colder than the freezing temperature of liquid. Okay, we call this supercooled. Supercooled. And essentially, we've talked about that water, when it freezes, the molecules have to get organized, right? They have to form kind of that pattern where they get stuck. And essentially, when something's supercooled, it is under enough pressure that it can't expand to form a solid. But if you give it space and give it a nucleation site, it's going to very quickly solidify if it gets a nucleation site, if it's exposed to a solid. Okay, so back up to our question, are those tiny little liquid droplets going to get 1,000,000 times bigger? Two things have to happen. They have to bump into each other, which is a collision. So we call it the collision coalescence process. Coalescence. Okay, the process is a theory of raindrop formation in which warm clouds, in which large cloud droplets collide. Again, they just hit each other. And when they hit each other, they stick together. And they grow together, eventually getting, again, at least 1,000,000 times bigger to form a raindrop. Okay, so we have lots of different kinds of precipitation. Which one falls depends mostly on the temperature of the clouds and the kinds of winds, right? So rain, obviously, if it's warm throughout the whole layers. Snow, if it's cold through all the layers, but some is, well, that should see. Sorry about that, there were some folks talking in the hall. So there's types of precipitation: rain, snow, sleet, glaze, which is shorthand for whatever reason for freezing rain, are all of our types of precipitation. Okay, so with your remaining time, you have an assignment to work on. It is over the notes that we took Friday. So that is binder page 111 to 112. Please don't turn it in early. Just wait until tomorrow and give it to me directly. It'll be a little bit simpler. If you get done and you don't have anything else to work on, the Quizlet is shared on Google Classroom. Please be mindful that your behavior affects others. Have a good one. See you tomorrow.